Welcome to the final section of How Hackers Actually Think. We've covered phishing, credential stuffing, social engineering, and ransomware. Now let's explore what many security experts consider the most dangerous and difficult to defend against attack vector: supply chain attacks. Supply chain attacks don't target you directly. Instead, they compromise the vendors, software developers, service providers, and other third parties that you trust and depend on. By compromising upstream suppliers, attackers gain access to downstream customers who would be much harder to compromise directly. A supply chain attack compromises a trusted intermediary to reach ultimate targets. Attackers will compromise the software vendor whose application a bank uses. They'll inject malicious code into that software. When the bank installs the update, they unwittingly install the attacker's malware. The bank's defenses never see the attack coming because it arrived through a trusted channel, as one example. This approach exploits trust relationships. Organizations implement security controls for untrusted external threats, but they necessarily trust their vendors, software providers, and service partners. Supply chain attacks weaponize that trust. Supply chain attacks offer attackers several significant advantages over direct attacks. First, they provide access to multiple targets simultaneously. Compromising one software vendor whose product is used by thousands of organizations gives the attacker access to all those organizations at once. One compromise yields thousands of victims. Second, they bypass traditional security controls. Security tools monitor for threats from untrusted sources, but software updates from trusted vendors, communications from known service providers, and access from authorized managed service providers all bypass security scrutiny because they're expected and trusted. Third, they leverage existing access and privileges. Vendors and service providers often have privileged access to customer systems for support and maintenance. Compromising the vendor gives the attacker that same privileged access. Fourth, they're difficult to detect. The malicious activity appears to come from a legitimate trusted source. There's no obvious indicator that something is wrong until significant damage has occurred. Fifth, they scale efficiently. The effort to compromise one vendor provides access to many victims, making the return on investment extremely favorable for attackers. Modern business operations depend on extensive networks of trust relationships. Organizations trust that software from major vendors is secure, and so on and so forth. These trust relationships are necessary. Organizations cannot independently verify the security of every single vendor all the time, inspect every line of code in every application, or audit every service provider constantly. There's an initial process, but they have to eventually trust their partners. Attackers understand and exploit this necessity of trust. Supply chain attacks come in several distinct forms, each exploiting different aspects of supply chain relationships. Software supply chain attacks compromise software during development or distribution. Hardware supply chain attacks involve tampering with physical devices during manufacturing or shipping. Service provider attacks compromise companies that provide IT services to multiple clients. Open source supply chain attacks target dependencies and libraries used in software development. Each type has different characteristics, but all share the common feature of attacking through trusted intermediaries rather than targeting victims directly. The SolarWinds attack represents one of the most significant supply chain attacks in history and illustrates key principles. In 2020, sophisticated attackers believed to be a nation-state group compromised SolarWinds, a company providing IT management software used by thousands of organizations, including major corporations and government agencies. The attackers inserted malicious code into SolarWinds Orion software updates. When customers installed these updates through their normal patch management processes, they unknowingly installed backdoors, giving attackers access to their networks. The attack remained undetected for months. Approximately 18,000 SolarWinds customers installed the compromised updates, though the attackers focused their exploitation on a smaller number of high-value targets. This attack attack demonstrated that even security-conscious organizations with substantial resources are vulnerable when software they trust is compromised. The malicious code was digitally signed with valid SolarWinds certificates, passed security scans, and arrived through official update channels. There's a profound observation from the philosopher Honora O'Neill in her book, A Question of Trust. She wrote, "We cannot have a complex society, a sophisticated culture, an intricate economy, or advanced technology without trust. The reason we need trust is not in the first instance an ethical one. It is simply that without some trust, even if it is no more than presumption or routine reliance, we would be simply unable to function in the everyday world." O'Neill identifies the fundamental role of trust in complex systems. Modern organizations depend on supply chains precisely because they enable specialization and complexity that would not otherwise be possible. But this necessary trust creates vulnerability. We must trust our vendors because we can't build everything ourselves. We must trust our service providers because we can't maintain expertise in every domain. We must trust our software suppliers because we can't write and audit every line of code we use. Supply chain attacks exploit this fundamental requirement of trust. The more complex and interconnected our systems become, the more we depend on trust relationships, and the more vulnerable we are to attacks that compromise those relationships. It's a fundamental tension between the complexity that enables modern capabilities and the trust vulnerabilities that complexity creates. And as we talked about, supply chain attacks have a multiplier effect that makes them extraordinarily impactful. One compromised vendor affects all their customers. This cascading effect means even small vendors can be valuable targets if they have the right customer base. A small software company whose primary customers are financial institutions becomes a high-value target. Attackers think strategically about which supply chain targets provide optimal access to their ultimate victims. As industries consolidate around a small number of major vendors, supply chain risks increase. When thousands of organizations all use the same cloud provider, email service, or enterprise software, compromising that single provider affects enormous numbers of victims simultaneously. The efficiency and benefits of standardization come with increased vulnerability to supply chain attacks. And of course, supply chain attacks are particularly difficult to detect because they arrive through these trusted channels. And the attack might remain dormant initially, activating only after widespread deployment, when detection would be most difficult and response most complex. Organizations often discover supply chain compromises only after the significant damage has occurred, or when the compromise is publicly disclosed by security researchers or compromised vendors. And the response is extremely complex. Victims have to determine if they were actually affected. Did they use the compromised product? Did they install the compromised version? Was that activated in their environment? Was the attack activated in their environment? They have to hunt for indicators of compromise that might be subtle or unique to their environment. Remove the compromised software while maintaining business operations that depend on it. They have to determine whether the attackers achieved objectives beyond simply establishing access. Coordinating response across thousands of affected organizations simultaneously drains both vendor and victim capabilities. The scale makes individual incident response extremely challenging. Vendors want to minimize reputational damage and liability. They might delay disclosure while attempting to remediate internally. They might minimize the scope or severity when disclosing. They might provide incomplete information about what was compromised. This creates information asymmetry where victims don't know what they need to know in order to protect themselves. By the time comprehensive information becomes available, attackers may have accomplished their objectives. Regulatory requirements for breach notification don't always apply clearly to supply chain compromises, and enforcement of disclosure obligations is inconsistent. You may have heard trust but verify as a best practice sometimes, but verification of supply chain security is extremely difficult. How do organizations verify that their software vendors consistently maintain adequate security? Reviewing security questionnaires and attestations is superficial. Conducting security audits of vendors is expensive, and vendors sometimes resist. Inspecting source code for every application is impractical for most organizations. The complexity and volume of supply chain relationships makes comprehensive verification impossible. Organizations must selectively verify their most critical vendors while accepting risk with others, and they're always accepting risk, even when verifying. Vendor contracts often fail to adequately address supply chain security risks. Contracts might not obligate vendors to maintain specific security standards. They might not require timely disclosure of security incidents. They might not provide adequate liability for security failures. And they might not grant customers the right to audit vendor security. Even when contracts include security requirements, enforcement is rather challenging. Contract damages rarely compensate for the actual harm from supply chain attacks. Many significant supply chain attacks are attributed to nation-state intelligence agencies rather than criminals. Nation-states have resources and patience for long-term operations that criminals often lack. They're interested in espionage and intelligence gathering rather than immediate financial gain. They target supply chains specifically to reach government and critical infrastructure targets that have strong direct defenses. The SolarWinds attack is believed to be Russian intelligence. Other supply chain attacks have been attributed to China, North Korea, and other nation-state actors. This nation-state involvement means some supply chain attacks are effectively acts of espionage conducted through commercial infrastructure. Traditional cybersecurity defenses and law enforcement responses that work against criminals are less effective against state actors. Small and medium vendors often have less sophisticated security than their large customers, making them attractive targets. Large organizations implement strict security requirements for their own employees, but less oversight of small vendor security, creating an asymmetry attackers exploit. Managed service providers, MSPs, are particularly attractive supply chain targets because they maintain remote access to multiple customer networks. They provide IT management, monitoring, security services, and support to businesses that cannot afford dedicated IT staff. They need privileged access to customer systems to perform these functions. Compromising an MSP provides the attacker with credentials and access to potentially hundreds of customer organizations simultaneously. MSP security becomes critical not just for the MSP but for all their clients. Several major ransomware campaigns have specifically targeted MSPs, using the compromised MSP access to deploy ransomware to many customers at once. Modern software development relies heavily on open source libraries and frameworks, creating supply chain risks in the development process itself. A typical application might include hundreds of dependencies. Open source libraries that provide functionality the developers don't write themselves. Those dependencies have their own dependencies, creating layers of transitive dependencies. If any dependency in this chain is compromised through malicious code injection, compromised maintainer accounts, or dependency confusion attacks, the application that includes it becomes compromised. Organizations often don't even know what dependencies their applications include. They don't track what open source libraries they're using. They don't monitor for compromises in those libraries. They cannot easily determine if a reported vulnerability in an open source project affects their applications. Understanding supply chain attacks should inform organizational security approaches. Maintain inventory of vendors, service providers, and software dependencies as much as you can. Assess criticality and risk of each supply chain relationship. Implement contractual security requirements and incident notification obligations for critical vendors. Monitor vendor security incidents and vulnerabilities. Have incident response plans specific to supply chain compromises. Consider vendor concentration and whether diversification would reduce risk. Implement zero trust architectures that don't automatically trust vendor-provided software or service provider access. Segment networks to limit what vendors can access, and monitor vendor activity for anomalies. Accept that perfect supply chain security is impossible and focus instead on managing risk and building resilience to supply chain compromises rather than expecting to prevent them entirely. Supply chain attacks will likely increase as direct attacks continue to become more difficult, and simply because of the benefit of hitting so many with one success. Supply chains are becoming more complex with more dependencies and integration points. Cloud services create new supply chain relationships. IoT devices introduce hardware supply chains into areas that were previously software only. Governments are beginning to address supply chain security more through regulation. Software bill of materials requirements attempt to improve visibility into dependencies. Security requirements for government contractors extend to their vendors and subcontractors. Critical infrastructure sectors face supply chain security regulations. The U.S. executive order on improving the nation's cybersecurity specifically addressed software supply chain security. The EU is implementing supply chain security requirements through various regulations. These regulatory approaches will likely expand, though their effectiveness remains to be determined. In our next lesson, we'll talk more about supply chain compromises in detail.